Welcome to question 3 of the 2015 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 3 we're asked to evaluate the definite integral between 1 and 4 of 1 divided by the square root of x with respect to x. So we can remember that the fundamental theorem of integral calculus says that if we want to evaluate a definite integral between a and b, where f of x is the expression with respect to x, then we simply calculate the antiderivative, which we're going to represent with capital F of x, and we're going to evaluate that between a and b, which can be done by substituting in the upper terminal of b, and then subtracting away the antiderivative with the lower terminal substituted in, which is a. So for this question, the first thing we're going to do is we're going to express this integral between 1 and 4 with a exponent. So instead of 1 divided by the square root of x, that's the same as x to the power of negative a half, and that's with respect to x. And then we're going to calculate the antiderivative, so we're going to add 1 to the power, which will give x to the power of positive a half, and then we divide by the new power. But instead of dividing by a half, we can multiply by 2. So we get 2x to the power of a half, which is the same as 2 times the square root of x. And we're going to evaluate that between 1 and 4. So next we're going to substitute in the upper limit, so it's going to be 2 times the square root of 4, and then we're going to subtract away from that 2 times the square root of the lower limit substituted in, which is 2 times the square root of 1. So that's going to equal 2 times the square root of 2, which is 2, and 2 times 2 is 4, and then we subtract 2 times the square root of 1, which is simply 2. So overall, the answer to this question is 2. And from the examiner's report, we can see that 55% of students got this question fully correct, and that for such a simple question, it was not well answered during the exam. A range of incorrect antiderivatives were given, the majority of which seem to involve logarithmic functions rather than just x to the power of negative a half giving 2x to the power of a half as its antiderivative.